Good morning. Thank you for coming this early to a presentation. I hope you're going to have a lot of fun today. My name is Dragos. I'm a solution architect for Adobe I/O, and I'm going to show you what we're doing with at Adobe, and then I'm also going to show you how we use Nginx in Adobe in some of the use cases and some of the lessons learned. We've been working on what I'm going to show you for about a little over 1 year when we started prototyping with Nginx. So what you'll see is kind of, 1 year worth of work. I'm going to start with a demo. I'm going to move into a product. So at Adobe, something very cool happens. Like we take some of the capabilities that are only available in desktop applications, very cool capabilities from desktop products, and we try to push them to mobile devices, such as my iPad, from which I give this presentation. And we use the cloud to do a lot of processing. So let me give you a demo. For instance, I just took a picture from a place in Dubai. And you see here I have some elements in the background and a building to my right. So let me show you what you can do right now. So this is a Photoshop Mix is like a very small and short implementation of Photoshop. It just offers just enough tools to do some editing on your photos and mix a couple of photos. So here's what I'm going to do. I'm going to more edits. I'm doing content aware fill. And I'm going to select this region here. And this one here. And let me select also the boat. Something like this. It's visible, right? You see that I selected. So then I go and push fill. And what's happening is that this image is being uploaded into the cloud. The cloud does some magic, and then the image would get back to me. There you go. That thing is not there anymore. Let's try some other things. For instance, I don't like this right area, right? I'm just going to select it. Yeah, like this. You see how easy it is. Anyone can do this now. Not sure if you ever used Photoshop so far, but previously you had to go and trace every corner, everything, right? And do all this. I don't have a demo right now. Look, boom, it's gone. Everything is gone. And then when everything, if I also want to remove this person, I can just do the same thing. So, right? It's like so easy to do now. And there are also demos, you can Google them if you want, where even they did this with a cat. So you know the cat has like a thin hair. So the the content aware field didn't work here. But it basically, this is just a feature that looks in the picture around it and then tries to sample the same thing. Yeah, this was not the best sample. So behind the scenes, all this communication with the cloud and everything that's happening is powered by Nginx. So we use Nginx as a proxy for this. Let me show you another quick sample with the cloud. Of course, once I edit something on my iPad or on my phone, via the cloud, everything gets synchronized with my desktop. So I can start working with my desktop. Another sample on how we use the cloud is like this is an application called Brush. So with brushes, you can take pictures out of anything in the world and make your own brush. For instance, somebody took a picture with a part of a grass, right? And here's what you can start doing with it. So you can just start drawing and imagining all these interesting things. So literally, you take a picture out of anything and you create your own brush. It could be a nice sky, a sunset. This is very powerful for creatives. Okay, let me go back. Of course, you can also share your brushes. Like this brush is not mine. I just got it from online, from the community. All right, let me see you another application. This is the last one. It's called Adobe Line. Adobe Line, again, is for doing sketches, for designers that are on the run. They want to do this. So for the first time, with some tools like, see if I have it here, yeah, like a pen and a ruler, designers can interact with a device and draw pretty precise things. Let me show you something. I'm going to put the ruler on my iPad, and you see the moment I put it, you're going to see some lines there, right? So right now, for the first time on an iPad, designers can draw perfectly straight lines. Look at that. Perfectly straight. Perfectly straight, right? You can do 3D perspectives and a lot of stuff here. And just to give you a quick sample, this is drawn on the iPad. This architecture stuff is drawn on the iPad. Also, a nice feature is that whatever you draw here gets synchronized with the cloud. And then even if I'm coming back after I don't know, maybe 2 weeks after, I can go back in time and see what I drew and see the whole history like this. So this is not a picture, what you see on the iPad. It's actually a real drawing. So this is pretty cool, right? And I think in this room, we're going to be the only one excited that we use Nginx behind the scenes, right? Because in real life, what people see are just these cool applications and the cool services, right? But in this small room, we can all be excited for half an hour about that. So let me show you now how we did it. And I'm hoping this will be good, and I'm hoping you will be able to learn something new. All right, I apologize. This is the first time I'm presenting with an iPad. Okay, right. Okay, so we saw some of the demos. There are other applications that are using this, and you can also download them. There's Lightroom Mobile, if you know Photoshop and Lightroom. Ideas. There's just a bunch of applications that use what we call Creative SDK. So now this SDK is primarily used by Adobe applications right now, but the interesting thing is that this SDK is open and other third-party developers can also use it. Even you can create your own application. I wouldn't be surprised if later on, months down the line, of a real photo camera with a touchscreen would embed some of the capabilities to basically remove from the pictures. Yeah, the site is, if you're interested in creativesdk.adobe.com. Okay, so now let's move behind the scenes in the time that we have left. Basically, we're building a few components in the API platform at Adobe. When you expose an API, you have somebody that exposes an API and somebody that wants to consume. So this is how the story starts. And then you realize that when you have to expose an API, you want to put some security in place. And after you push the API and somebody is really using it, you want to see some metrics to see the usage and how things go. And then if you're really successful, then you may consider making some money out of these APIs. And then in the midst of all these, you have a gateway that talks with all these layers and makes sure that things happen as they're supposed to happen. So, of course, today I'm going to focus on the API gateway, which is the show runner. When we started this back in September last year, we just knew that we want to have a simple gateway that is simple to configure, that is simple to scale, secure, and super fast. So we looked at some web servers online, and we were already using a solution from a third party to do API management. Because it's not just the proxying, it's the whole ecosystem around. Again, is the throttling, is everything that comes with exposing an API. So we wanted to make it very simple and scalable we were looking to have something that is pretty low in the resources that it demands, that would be able to run in most of the computers. That's why we choose the Nginx, because it actually, not everybody, I don't want to say everybody, but majority of people who have a Java application, it's very common to find that they put an Nginx in the front. Java, Node.js, what I found, they put this in the front. So I said, wow, this is cool. What if how would it look like if we are to draw some of these rules in Nginx? The previous gateway that we were working with, it had some XML things that you had to configure, and you had to write an XML policy file, that's how they called. Yeah, and you would have to write those things, and how do you put variables in XML, and you would end up with really, really long XMLs that you would have to maintain. So in Nginx, we said, in Nginx, we said, okay, what are we doing in the gateway, and how can we express that? I've listed here some of the functions that we have in the gateway. There are some API gateways out there that do a lot more. But by looking at the way that Adobe uses, we found out that Adobe uses, of course, only REST, no SOAP for the APIs. Secondly, not even XML is not used because JSON is so popular nowadays. So I said, that's interesting. We're going to build a gateway that we don't want to support XML, and we'll see how long in time we can go. So now we're 1 year and a few months. We'll see how far in time we can go. But it only does JSON. And then, among other things, a gateway needs to authorize the application, as you saw, Photoshop Mix and others. Has to validate maybe some users, because maybe depending on your subscription, you may be allowed to more features in the application. It has to enforce some application plans and user plans. So I'm not sure if you're familiar with application plans and user plans, but I can give you a sample. A user plan can say, if you're a free Adobe Creative Cloud subscriber, you are entitled to do 5 of content-aware fields a day, right? That's a user plan. And an application plan may say the Photoshop Mix can do 5,000 of those each day, but not more. It's just a control mechanism, right, just to split the fair usage. So we put this in the gateway. And then, of course, if you don't have a firewall in the gateway, it's difficult to implement some of the rules. And then there are these components that collects usage and performance data, helps you to do some cloud tracing, and then it sends the data to a monetization engine that just runs a bill at the end of the month. So these are pretty much the feature that we identified out of, I don't know, a couple of years of work, that these are the most common things that are happening. So no XML, JSON, no SOAP, only REST. And these are the validations that are happening in the gateway. So when a request comes into the gateway from any application, we need to have some set of validators to see what's happening there. And then we push some data for some usage data. That's for metrics and for monetization. So we said how it would be if we can just list these configurations like this easy. Whenever we have to authorize an application, just validate an API key, because that's how an application identifies. If we have to validate a token, what if we say validate user token on or off and make it like this simple? And the same for the plan. Because when you shape your location in Nginx, and I'm so excited that now we know how this works, hopefully. So I'm happy to share this with you. You know that when you write a location block, right, you can just simply configure it, and you can eventually end up with something like this. Here, make it bigger for you. So this is a vhost, and then you can just say what I want to validate for this location. As I said, the API key, users, and throttles and proxy. Yeah, you just proxy pass to the other service. And at the end, what I did not add, of course, you have the logging phase in Nginx where you just send the data. And we also imagine, if we build this in Nginx is so light, then Java applications may just, instead of installing the standard Nginx, they may install this API gateway, which doesn't take a lot of resources from your machines. It turned out eventually that it's not such a big delta if you host this gateway like in separate machines, and you maintain them, and then you do a VPC peering with the services in the back. But I'm going to get to the Amazon deployment shortly after this. And after we did this type of validation, we realized that, for instance, to validate, we don't want to validate everything upfront. Like, for instance, if the API key is not valid, what's the point to validate all the user and the app and the plan? So we had this need to put these validators in some orders, right? So you see here, validate API keys on, it goes to an internal path to validate, and the order is 1. This means they execute in parallel. So we set order 2, order 3, so that you can just play with this. At the end, like when you do the proxy pass, you also have the option to use some of the variables set by any of these validators and send them to the backend services. For instance, if the gateway has already validated the user token and we already know who the user is, we can just simply pass X user ID in a header, and then the backend service doesn't need to do any validation. This pattern is nice because you write your service and you don't care what authentication and security is going to be in that service, because that's the gateway, so you keep the service clean. We built this in Lua with OpenRest, and I think in the next presentation we're going to find out more from what's cooking in OpenRest. But what we also want to end up with is something even more generic that is baked into Nginx. Something like there is the you can keep me honest here, a module that does the authentication right now in Nginx. It's the I forgot the directive. It's the authenticate. Yeah, there's one directive that you can use that basically, if that you call another path in Nginx, and if it doesn't return HTTP 200, then the whole request is failed, and it's failed with like 401 or 403, something like that, and you can customize. But what you cannot customize is that you cannot use the request context variables and use them, to process the request as I was showing you earlier. We want to pass the user ID, for instance. So in that sub request, everything is locked there, and everything happens there. So we weren't able to use that specific module. So these are some specifications on how we were looking to validate, and we're open to make this public, and also to make the code that we wrote, the Lua module, which is really a thin layer on top of the massive work in OpenRest on how to validate the request. And one of the reasons why I'm also here and sharing this with you is that in case you want to collaborate and have ideas, if there's any value in standardizing how one request can be validated into a gateway or even in Nginx, we're open to discuss. There's another session today about how you can do LDAP authentication, right? So people start using Nginx more and more, and they even start to put some validators in place. That's how we see them. If it's LDAP or if it's OAuth 2.0, what is really the difference? You validate the user, right? So how is that happening? All right, so here's how the API gateway ended up looking in the end. We have the OpenRest with all the bells and whistles and the cool stuff in it. OpenRest, of course, embeds Nginx, and then we've added our custom modules. We have something that does the request validation, which is what I just showed you. We have an asynchronous logger module. So this was very useful because we were kind of hurt even when we wanted to write the access log, because every I/O has a penalty. And when you go in the cloud, that penalty kind of starts to bite you. If you're talking about maybe 10,000 requests per second, you don't feel. If you talk 20,000, you don't feel. Above 20,000, you start feeling the difference. You start feeling the difference, 20,000 requests per second in one single node. If I recall correctly, I did this test in 2013 in December. It was like cutting maybe 20,000 requests per second because I was writing in the log. Of course, the write is synchronous. What do you do about it? And what do you do if you want to send that data then to, as I was saying, a backend service to process and get the usage data and even monetize that? You don't want to interfere with the real call. One of our goals was that if we put a gateway in front of all these services, it has to be like as transparent as possible, and the request should only take up to 100 milliseconds. So to sustain at least a minimum of 100,000 throughput per second, you have to do things as synchronous as possible. I mentioned that we run this currently in Amazon for now because we found Amazon to have enough tools that we can use and get this going. Like we use Route 53 for our Adobe I/O domain. Let me make this bigger. Is this better for you? So the request comes into Route 53, where we host the Adobe.io. We have one virtual host per each service. What you saw there with the synchronization, you see is the API storage Adobe I/O, and then there's Behance. Behance is a community of creative. That's where I got the architecture stuff that I showed you from. So each service dwells in its own vhost. This is also for the fact that we don't want to have the services fight against each other, like, oh, a customer should be represented like this, and you already have this path/customer, and now what do I do? What fields do I put in there? So we said, you know what, we're going to just put each service in its own vhost, and you're free to, basically write any path you want. And then the call hits an ELB in Amazon, and then the request goes into the VPC where our gateway is stored. We store all the API keys, and we try to cache as much as possible into Redis. Like if we figured out that a token is valid, we store it there in Redis. Whatever other validations that the gateway does, we also try to put in Redis. Redis is pretty good. It's pretty good to use, and you can use it if what we noticed in Amazon, as much tuning as we were doing, is good up to 60,000 requests per second. But if you want to have Redis do more than that, you just can't, because I don't know exactly the internal of how Elastic Cache runs in Amazon. But I'm assuming it has something to do with the way that their boxes are made. And we're not like a typical use case, like how many really do go to peaks of 60,000 requests per second. So for maybe 99% of the cases, this may be good enough. Depends how. Yeah, it also depends on how much traffic you do. And then remember that I showed you those configuration files for the services. We store those in S3, and there is a job in the gateway right now that goes I think it's every 5 minutes, and goes and tries to reload all the configuration files from S3. We would like to get to a model where when we edit a service, we can just tell all the gateway nodes, there is a new service, please reload. But this was just the simplest thing that worked. And the nice thing about it is that the reload in Nginx doesn't cut the connections. All right, and then after the request comes here, it's validated by the gateway. The last part is just to send the request through to the API service provider. As you see here, I listed the VPC peering. I'm not sure if you're familiar with the VPC peering. This is just basically a service offering for Amazon that you can do your own 2 VPCs. And then you assign some groups to those. And then you can define a rule like this VPC peering is only accessible from the public internet via the gateway. So security-wise, and like at the network level, you cannot reach any of those services but through the gateway. This was very important because the whole security stuff is in the gateway. But we also support the other model where the connection can be over the internet. It's HTTPS in most of the times. But that turned out to be like a long story, and we're still struggling to make HTTP performant. And now HTTPS performant, and now I think the latest security, the SSL certificate has it's like 2048 encryption. It's like huge. That takes a lot of the resources, and the poor ELBs, when they send like 100,000 requests per second, they're like, what do I do with this many? We are really having these struggles in the public cloud. Any questions so far on the Amazon deployment? This may be new to you, so I don't want to move. But if you have questions, feel free to interrupt me anytime. Do you have any questions here? Yes.
What would you use also to maintain the gateway?
So the question was, why don't we use apps? The chef service from Amazon. I'm not familiar with that with that. Maybe you can fill me in after the presentation. Yeah. Okay. Are there other questions here? Yes?
Have you guys looked at building your own load balancer instead of using ELB?
The question was if we looked to build our own load balancers. Yes. Yes, definitely. We would love to do this even in Nginx and make it the ELB and the gateway itself. Yes, that's a very good question. We didn't find like there's a lot of out-of-the-box things there. We also tried to offload the SSL termination into the ELB, and the security team was more comfortable to do that. But I think it's a really nice model. And another thing that the ELB does, so we ran some tests with the plain vanilla Nginx with SSL termination there, and with the ELBs. And when you are in the cloud, what the tests showed is like you get a similar throughput. Maybe we had to put more instances, and that was mainly because of the SSL termination. And then there's also another thing that the ELB does, that it delays a little bit, like it puts all the requests in the queue. And we don't have this capability in Nginx to make a lot of these asynchronous things, but that's what we're working on. So if you have some interest in doing that, I can speak more. I would love to connect with you. Okay. Any other questions here? All right. Let me move forward. A few words on the performance. Just want to share with you in Amazon. We did this test with 9 C3 to extra large nodes. It's in the header. And a pre-warmed ELB. Now, a pre-warmed ELB, for those of you who don't know, who are not familiar, is pre-warm means that you put a number of nodes behind the ELB. Eventually, an ELB is just a cluster of EC2 nodes that run together and process your requests. So we pre-warmed the ELB with 18 nodes, M2 medium nodes, and we started 9 C3 to extra large API gateway nodes running Nginx. This gives you 4 CPUs, so we configured Nginx to run 8 processes. Because we don't do the SSL termination on the nodes, we said, okay, we can make 2 processes per CPU. So the throughput was pretty good, was decent. We were able to get to 142,000 messages per second. And the response time, the average response time was somewhere between, well, I guess the average is between 40 and 42 milliseconds. And that implies all the validations that I mentioned to you, like authorize applications, validate API key, validate any tokens, throttle limits, and all those bells and whistles, which is pretty fantastic. We don't take credit for this. We give credit to Lua, because Lua processes pretty fast. We just wrote some layer 2 levels of cache, and we try to keep as much as possible things in memory. So now this is with a request that stops in the gateway nodes, is no reverse proxy whatsoever. In the next slide, we also ran with a reverse proxy scenario, the same thing as you saw before, and this time the throughput is in half. And please look at the average response time. It also doubled. So it kind of makes sense. You have higher response time, like double. Remember, we were like looking at 40, 42 milliseconds, and now they're like 78, 80 milliseconds, right? So this may be an explanation for the throughput. It's good to look at these things. Basically, the throughput is an indicator of how fast the gateway nodes can process stuff. But if you take, again, if you take the ELB layer out, if you take this single node, EC2, C3 to extra large node in Amazon, and you hit it from within the same VPC, you get 100,000 requests per second easily. Easily. You put all those layers on top. You put a single API gateway node, a pre-warm ELB, and the throughput decreases by 80%. It's, you gain something, you lose something. Of course, again, the ELB does the offload, the SSL offloading, makes a queue of the request, and so forth. But I thought this is interesting to share with you in case you want to run in Amazon, or maybe you're already running. If you have better performance numbers, please share them with me. I'm really interested. We spend so much time with Amazon trying to tune this. Is as much as possible. Again, maybe our use case may be very particular because we need to support at least double of what you see right now, and in the future it may grow up. So we don't want to be caught by surprise with a growth that goes high logarithmically, and then we say, oh, we can't support. We're also looking at other clouds. Of course, Google Cloud, Azure. We didn't do much tests. From what I heard, the differences are not so big. So I remember seeing performance tests done with the Google Cloud Engine when they hit 1 million throughput. If you Google 1 million throughput Google Cloud Engine, you'll see that they use about 99 machines behind. So if you put the 99 machines and you look, this is 9 machines running 100,000, so maybe with 99 you can do that. But there is a limit on the ELB, so there is I think it's a maximum number of 82 nodes per ELB, so that's where the cap is. It would be really, another ELB solution in Amazon would be a really good thing, which would be more performant. But again, maybe we're dealing with a use case that is only particular to us. However, in the future with the Internet of Things, I don't think, like if not many companies have this problem right now, it doesn't mean that in the coming days, years, companies won't be having this problem. I also wanted to show you something from the real production stuff, but yeah, of course I had to take out which service it is. So this is with larger payloads, like files, as you saw the pictures that we transfer. We were able, this chart shows 1.6 million requests. The average response time was 5 seconds. Again, take into consideration there's some processing, there's some GPU there in the cloud. And here, look at the latency that Nginx adds. Basically, you were supposed to see the difference between the delta between the green lines and the red lines. But you can see it's like very noticeable. Probably here at the end, you can see some difference. So we said, okay, maybe it's not noticeable because it's a larger payload, and that the scale, the vertical scale of this graph is in seconds, and you see the middle is 10 seconds. So you cannot really see. So we looked at another test that shows with the smaller payloads, so that the scale, the latency scale is smaller. So now the latency scale is 0.5 seconds. And when you look at the graph, there's a peak here. The maximum peak was 100 milliseconds. So I don't take the glory, you know. We're very, very happy with OpenResty, very happy with Nginx. It's just really nice, really nice. Yes?
The total error is like 503 for those service timeouts?
They don't include the service timeout.
So what are your errors?
I would have to look. Let me see if I can remember. Those are usually the errors that have been returned by the backend service provider. Which, yeah, in the back end, you may have another ELB in that service. So, yeah, we weren't particularly interested in the errors. So we processed 10.8 million requests to have 106,000 total errors. The timeouts are still ongoing conversation, and every time the traffic spikes, you have, of course, an increased number of timeouts. We're still learning how to monitor those, how to identify that this is really critical. So far, these are less than 0.6% of the traffic. I agree that we have to do something. At the same time, we tell all the applications that are using the services to not lean on the fact that if they make a call, that's going to succeed 100%. So in the SDK, in the Creative SDK, there's a mechanism to retry, and we'll keep on retrying, we'll keep on retrying. So eventually you'll pass the timeout unless there's maybe a race condition there. Yes? No, it was also from a real server, from real. The previous ones, these are only benchmarking. So we use a tool. This is a screenshot from a tool, Soasta, that we use, and we basically try to see how much the gateway's node can take, which was the previous slide. This one with 140,000 messages per second with nine nodes, and then in this next slide we also added the reverse proxy scenario. So The tool that we use is Soasta.
Oh, okay. Thank you.
Yeah, Soasta. Soasta is a pretty cool tool. The QE team is interesting. Again, if you want to test performance, there are some challenges here. I'm still looking, like, I was even looking yesterday for another tool that is easy to automate. And in the market, I wasn't able to find.
But isn't Swasta running in EC2 also?
Soasta runs in EC2.
Connecting data center to data center, right?
Yes, and you can also run it in Google. They have integrated with Google. Yeah, but you have to spin like 6,000 virtual users to run this test. If you do performance, like we tried a tool, not sure if you're familiar with Tsung. I'm not sure if I call it correct. Tsung or Tsung. Tsung. You just start 3 machines and generate 200,000 requests per second with 3 machines in Amazon. In this test, we had to spin up like 50 machines to generate, like, if I'm correctly, I may be wrong, so I put this star, to generate 6,000 virtual users, because I think the QA team, I think they use about 200 users per machine. I can be more precise. If you have questions, I can ask them, and then I can answer. So don't take what I say for granted. But I know we spin a lot of machines, and for this particular case, it's difficult to quickly try new things out, spin machines. It takes time to spin 50 machines. Yeah. So it's not best. I hope that the market is going to come up with a better and more performant solution to make it easy to run performance tests. I know that tomorrow there is a session here about performance testing Nginx. So if you guys are interested, it's tomorrow. It's another cool session. Real quick, in the minutes that I have left, some of the lessons learned. First of all, be mindful about resources. From a single network card, you can only make this many network connections, right? Socket connections, that's it. You're capped at 64,000. Be mindful of that. Be mindful how many connections you keep open. Network congestion is also important. When you have bigger packages that compete with smaller packages, the bigger packages would always be sent first as opposed to smaller packages. So for this reason, we're investigating ways to tune and run different gateway configurations depending on the payload. If you do video encoding or image processing, you will go through a gateway, but if you do small payloads, you will go through another gateway, so that we can, all the packages have, in a way, a fair share of priority. And asynchronous is just critical. I cannot enforce this so much. It's so easy, like when you run tests, and sometimes you do a chattiness between like the gateway and the cache, and the Redis cache, and you do some commands, and then soon after you find out you do like 3-4 requests that cuts from your ports. It congests the network, and if you do that synchronously, then that's blocking. So that's not good. Asynchronous is very, very important. OS level tuning is also important. We spent a lot of time, and usually this should match your type of payload, like how much memory you allocate per request. That's usually an indicator. We look at the analytics and see what is the average payload size. So we try to make enough memory for that average payload size. And all these things, I will be sharing the presentation with you afterwards. DevOps team, that was a real success for our team. We work in a DevOps team. It's scary at times because everybody in the team has access to production. You do one single mistake in Route 53, the whole thing goes down. We had to change something from CNAMEs to A records in Route 53. The TTL was set to 900 seconds. We did that change. For 900 seconds, no access to the services was possible. It looks like in Amazon, when they changed from CNAME to A record, there's something in the DNS. So we were just, helpless, looking and counting the seconds, 900 seconds, with CSO all over around us. What's wrong? What's happening? But we only had one incident in 1 year, and the uptime was actually, we were able to hit 100% uptime. So that was, it was pretty cool. I think DevOps team, if you guys want to try, I think it's interesting. You have to just trust the team. You have to trust the team and have enough audit in place that if something happens in Amazon, that we have backups and we have all this in place. We also use Chef, so that's tremendously helpful. We're using Chef right now. We're using Chef. We want to try Mesos and Docker and try to automate and treat the infrastructure as a code. Testing is never enough. I just added this here. We have a nice testing framework for Nginx. It's awesome. So I encourage like everybody to use it because it's so cool. And yeah, somebody here in this room made a lot of effort to make this happen. I really love it. Just love it. Love it. We have actually 60% of our code in the gateway is tests, and 40% is actually Lua code. Lua FFI is great. It can save you from troubles like with libraries when you don't have the library in Lua. Who cares? You just write the FFI interface. You get that. This is a sample showing. We had to do the Amazon signature, the V4 signature in Amazon, and we had no support back then in OpenResty. So I had to write my own stuff to sign the messages to go to Amazon. So I just used the OpenSSL methods from Lua. This is just amazing, awesome. And the same with ZeroMQ. Running out of time, I only have 2 slides left. Real-time monitoring and alerts are crucial for high uptime. This is like some of the tools that we use, and I think if we have more, we find out more, we're just going to use more. Like it's so critical to have more tools. Out of these tools, when we had the DNS outage, only one tool, which is Pingdom, was able to see. The other tools like RunScope and others, they were caching the DNS and they didn't signal anything. If we had only one tool, we wouldn't even know that that has actually happened. Looking ahead, we want to open source what you have seen today. We're open for collaboration, which is why I'm also sharing. If you're interested to even collaborate on the specs on how to validate a request in the gateway, open for that in the source code as well. Streaming uploads is also important. Better module packaging to load modules at runtime. Messaging support, we're working to integrate the ZeroMQ into the gateway and see some of the patterns that we can build there. And we're looking for more security controls. So if you have questions, this is my email address. More information about what I showed you, where Adobe I/O is being used, you can look on the Creative SDK at adobe.com or adobe.io, and it will take you to the same place. This is what we're doing. I hope this was useful for you, and I really had a great time speaking about it to you.